Okay, here's the solutions to the prep. And the first thing that I've done is to mark up the corresponding angles and the alternate angles here. So, and also the vertically opposite angles. So these angles, just one second, just turn this on here. So these two angles here, these are vertically opposite, so they're equal. So I've color coded them accordingly. These two angles here are equal. They're alternate angles, and so are these alternate angles here. They're equal. Okay, and what we're trying to do is to work out the length of PB, and PB is this length here. Okay, so what we're going to try and do is going to try and get the ratios of corresponding sides equal, because we're told that these are similar. Okay, so we're looking at getting corresponding ratios equal. So if we look at, first of all, we should note, by the way, that this triangle is smaller in dimensions than this triangle. Okay, so you need to remember that. So let's have a look, first of all, at the side between the green and the blue. So that's 6 in this triangle, and between the green and the blue in this triangle is 15. So 6/15ths, and that's small divided by big, equals, now we're looking for small divided by big again. So we've got these two lengths that are corresponding, because this is between the blue and pink, and this is between the blue and the pink. So we're looking for small over large again. So small, that's the one that we're trying to find, divided by large, 12.5. Okay, so we get this ratio. So that's PB divided by 12.5. Got this ratio. We're trying to find what PB is. So we're going to multiply both sides by 12.5, and that will find PB. So PB equals 6/15 times 12.5. Okay, so let's get our calculator up here and get the calculator, and we're going to calculate 6/15 times 12.5, and we get 5. So PB equals 5 centimeters. Right, next question. This is a very similar idea. So the first thing I've done is marked up the equal angles again. So these are corresponding. These are corresponding. And here, these two triangles, this small triangle here is the same angle as the angle in the big triangle there. Okay, so we're dealing with this small triangle and this big triangle. Okay, and we're going to do the same idea. We've got to try and calculate now ED. So how do we calculate ED? ED I've called X on this diagram. So here we go. Now, we should try and get corresponding sides, so of the small triangle and the big triangle. So the small triangle is this one, and the ratio of corresponding lengths from blue to pink is 9 divided by, now the large one is this whole length down here, that's 9 plus 3, which is 12. So 9/12 is equal to, and then we can do the equivalent ones here for BE, so we want the small divided by large. Okay, so small divided by large. The small is the BE that we're trying to find. Oh, sorry, we're trying to find ED, I beg your pardon. So ED is this one. So we need the small, which is this 6, divided by the large, which is this length, and that's 6 plus X. Excuse me. All right, then we can just cross multiply. So let's do that. So we get 9 times 6 plus X, just cross multiplying, that's those multiplied together, equals 72. 6 times 12. Multiply out the brackets now. 6 nines, 54. 9 times x, 9x equals 72. Subtract 54 from both sides. 9x is 72 minus 54. So 9x is 18. So x equals 2. Now, in this case, because the triangles are one inside the other one, what we could have done is to set the ratio of that to that, so 3 to 9, is the same as the ratio x to 6. Okay, so this 3 to 9 is the same as x to 6. Could have done that as well. And if we did that, we'd then multiply both sides by 6, so you get x equals 3/9 times 6. 3 goes into 9 3 times, 3 goes into 6 twice, 3 cancels with 3, and we're left with a 2 at the top, so we get the answer of 2 as well. Okay, calculate the length of BE. So we're going to do the same thing. We're going to use our 9/12, so that's small to large, and now we're doing BE. And BE, let's call that Y, that's that length, and we want small to large again, so that's Y over 7. So multiply both sides by 7, so Y is 9/12 times 7. Now 9/12 can be simplified to 3/4, so we got 3 7s are 21 divided by 4, and if you wanted to, you could write that as 5.25 centimeters, or you could leave it as a fraction. Okay, question 3. So first of all, we've got these measurements. We're trying to calculate the length of CD. Okay, so that's this length here, CD. We'll call that X on our diagram. Again, we're going to do the ratios of small triangle. Remember, our small triangle is this green one, and our big triangle is the pink one. Okay, so that's what we're going to do. So we're going to do ratios of small to big. So the ratio of small to big, we're trying to calculate this value, X. So small to big, so 5 is corresponding to this one here. 5 divided by X is equal to, now we're going to do small, 4, over big, and that's 4 plus 6, which is 10. Okay, don't make the mistake of picking 6 here in this value, because the large triangle is 10 in length, not 6. Cross multiply, 4x is 50, so x is 50 over 4, which is 10.5. No, it's not. 25 over 2, 12.5. Or leave it as 25 over 2 if you prefer. Okay, now calculate length of ED. So we're calculating this length, ED, let's call that Y. So we're going to do small, 4.8, to big, which is this whole length here. That's 4.8 plus Y equals small, 4. So we use this 4 here, and big, which is 10. Okay, small over big equals small over big. Right, cross multiply, 4 times 4.8 plus Y is 4.8 times 10, which is 48. Multiply out 4 times 4.8, let's just quickly do that. 4 times 4 times 4.8, 19.2, plus, and then 4y is 48. So 4y is 48 minus 19.2. Let's work that out. 48 minus 19.2, 28.8. So y is 28.8 divided by 4, dividing both sides by 4. So divide that by 4 and we get 7.2. 7.2. Now we could also have done the same idea as before, so we could have done the green, so 4 to 6 is 4.8 to y. And if we'd have done that, we've got 4y is 6 times 4.8. So y is 6 times 4.8 divided by 4. And if we do that, 6 times 4.8 divided by 4, 7.2. Same answer. So that would have been easier. Okay. Question 4. Similar sort of idea. They're mathematically similar. So let's do the corresponding angle. So this angle corresponds to this one, clearly. This one corresponds to this one. And this one clearly corresponds to this one. Calculate the length of PR. PR is this one here, X. Call it X, why not? So here we're going to have big over small. It doesn't matter whether you do big over small or small over big. So X divided by 26 is big 12 over small 8. Multiply both sides by 26 now. 12 over 8 times 26. Calculate that. 12 divided by 8 times 26. There we get 39. 39 centimeters. Now calculate the length of BC. So that's this one, Y, BC. So we're going to do the same thing again. We're going to do, this time we'll do small over big. So we've got our small divided by our big is equal to small 8 twelfths. Okay, small over big. Multiply both sides by 45. So we've got 8 12 over 12 times 45. We get 30. So notice we're doing these ratios, small over big. Just make sure you get the correct corresponding side. So again, this angle corresponds to this angle. This angle corresponds to this angle. This angle corresponds to this angle. Right, so we're going to do, we've got to try and find CE. CE, that's this value X. Should we call it X? So let's do X, that's between the green and the yellow. So we need a corresponding green and yellow. That's 8 up here. Equals. And now we're doing some other two ones. So remember, this is larger. This triangle is bigger. So we did big, small, equals. Now we need big, 9, over small, 6. So they're corresponding pink, yellow, pink, yellow. Multiply both sides by 8. And we get 9 divided by 6 times 8, 12. So that's 12. Now calculate the length of BC. BC, that's, we'll call that Y. Do the same thing again. So we're going to do small divided by big. So small on that triangle, the one we're trying to find, divided by big equals small, 6, divided by big, 9. So Y equals 6/9 times 13.5. Do that, 6 divided by 9 times 13.5, 9. So Y equals 9. 9 centimeters. Next one, question 6. Here it tells us that the ratio of the lengths AB to AC is 3 times. So this whole length here is 3 times as big as this length. So this whole length is 15. 15, 3 times as big as 5. So if that's 15 and that's 5, this makes this 10. Just subtract them. Now we need to calculate the length of CD now. Let's call that x over here. So that's big. That's in the big triangle, this x. Big divided by small, and that's 4, corresponding side, equals, now let's do big. The big is 15. So that's that whole length divided by small, which is 5. Multiply both sides by 4. 15 over 5 is 3. 3 fours are 12. Now find the length of BC. BC. Well, we've already done that actually. So 10. We could have found this value a different way, but we already found that on the diagram, and that's 10. If you wanted to show that mathematically, we would say let's say we wanted to do big, which is 5 plus BC, over small, which is 5, equals big. So that's our x, 12 divided by 4. Multiply both sides by 5, so you get 5 plus BC is 12 over 4 times 5. And then we're going to subtract 5 from both sides. So BC is 12 over 4, which is 3, by the way. So 3 times 5 is 15. And then we're going to subtract the 5 from both sides. 12 over 4 is 3. 15 minus 5 is 10. So we've got the same answer. Question 7. Okay, show that these two rectangles with these given, so a 20 euro note is 133 by 72, and a 500 note is 160 by 82. Show that they're not mathematically similar. Well, if they were similar, I'd say if similar, then 133 small divided by big equals small divided by big. But that's not the case. These are not true. But this is not true. Because if you put these in a calculator, you get different decimals and therefore not similar. What?